We have solved systems of equations by using the graphing method, the substitution method, the elimination method. We have also used row reduction with Gauss-Jordan elimination, and now we're going to explore what we call Cramer's rule. So Cramer's rule is a way to solve a system, maybe to get the one value you need versus getting the solution to the entire system. So we're going to have some new vocabulary here. We have what's called the determinant, and the determinant is a numerical value. It is a numerical value. And we get that numerical value by setting up our determinant what looks like a matrix, but it's not. So these are just vertical bars versus a matrix that has little hooks on them. So this is a matrix, right? This is a determinant. Oh, yeah, I knew I was spelling it wrong. Let's try that again. Determinant. So we're going to have a 2 by 2 determinant. It's going to have an equal number of rows as it does columns, and we're just going to work with 2 by 2s because that's really all we need to work with here. You're going to take A times D, and then you're going to subtract from that B times C. So A times D minus B times C. Let me show you. Here we have a determinant, 3, negative 2, 6, 1. The value of this is going to equal 3 times 1 minus negative 2 times 6. So I'll use the highlighter to show you. 3 times 1 is going to be 3, and then we're going to subtract from that negative 12. And when you subtract a negative, it's addition. So we end up with 3 minus negative 12, which would be 15. So the value of that discriminant is 15. So the determinant is equal to 15. Now I'm going to not write out determinant number 1 because you can see that it's a long word, and I start as I'm reading or writing and speaking at the same time. I leave out letters. So I'm just going to call it capital D for determinant. So D is equal to 15. Okay, let's have you try one. So you try, what is the determinant of 4, 7, 6, look at that, 99. And I'm going to show you that 99 because I want you to try this, but then I'm hopefully going to show you a little shortcut to multiplying 4 times 99 so that you don't pick up your calculator, because the whole purpose of this is doing it without a calculator. So go ahead and try this and then come back and we'll reveal the answer. So 4 times 99 is 396 minus 7 times 6 is 42, and that is equal to 354. So let me show you how I multiply 4 times 99 rather quickly. I do 4 times 100 minus 1. 100 minus 1 is the same thing as 99, but rather than say 4 times 99, I'm going to do the distributive property, 400 minus 4. And that's how I can get 396 fairly quickly. Okay, so now it's time to explore Cramer's rule. Now that we know how to find the determinant, we are going to explore Cramer's rule. So we have a given system, ax plus by equals s, and cx plus dy equals t. x, the x value of the solution of the system, because the solution is going to be the x-y combination that makes both equations true, is going to equal the determinant of x divided by the determinant, and the solution for y is going to be the determinant of y divided by the determinant. Let me give you an example. 5x plus y equals 3. 10x plus 7y equals -4. Now we're going to be working with this system right here. Let me show you the determinant of x. The determinant of x, when I'm looking for the determinant of x, instead of in column 1 having the coefficients a and c, I'm going to replace it with the constants s and t. But notice how y stays the same. So I've got x, y. X is replaced, so we replace x with our constants s and t, and that's how we find the determinant of x. And then when we want to solve for y, we replace the y column, this is your y column, and you replace the y coefficients with s and t. And then of course your determinant is going to be your x and your y. So let's start there. We're going to find the determinant because we're going to need to find the determinant. Oops, let me use my highlighter here so you can see what I'm going to do. So we're going to use our determinant to figure out both values x and y. I promise you'll see that this is pretty easy. So the determinant is going to be 5, 10 lined up, those are your x's, 1 and 7, those are your y's. And the determinant is 35 minus 10, which is positive 25. Most excellent. Okay, now we're going to, let's find the x value. Let's find that in red. So D, the determinant of x is equal to, we're going to replace 5 and 10 with our constants, 3 and -4. And then 1 and 7 will remain the same. Okay? There we go. Isn't that beautiful? And then we're going to have 21 minus -4, which is 25. Okay. I'm almost there. We're now going to find the determinant of y. So the y's are going to be replaced with 3 and -4. And x's will remain, the coefficients of x's will remain, 5 and 10. And then we have -20. Is that right? -20 minus -30. -30, yeah. And that's a -50. That is right. That's beautiful. Okay. Everything's beautiful today. Everything is beautiful today. I hope that you feel the same. It's a beautiful day. So x is going to equal the determinant of x divided by the determinant. So the determinant of x is going to be this 25, and the determinant is 25. And that's going to equal 1. Y is going to equal the determinant of y, which is -50, over the determinant. of 25. So our x value is equal to 1, and our y value is equal to -2. So our solution is 1, -2. Okay, let's try that again. Here's another example. We're going to find the determinant, and we're going to find the determinant of x, and we're going to find the determinant of y. So if you did not understand that the first time, I'm going to take an opportunity to explain it once again. So I've got my overall determinant is going to be the coefficients of x for row 1 and the coefficient of y for column 1 and column 2, not row. Column 1 is your x's and column 2 is your y's. And then the determinant is going to be 3 minus -12, which is 15. Now we're going to find the determinant of x. The determinant of x, we replace the coefficients of x with our constants. So these are our constants. And then we have the coefficients of y in the next column. So it's -2 and 1. So 4 minus -26 is 30. Then we have the determinant of y, and the determinant of y, the x coefficients stay, but then we have our constants replacing y, and our constants are 4 and 13. So that's going to give us 39 minus 24, which is 15. So D is 15. The determinant of x is 30. And the determinant of y is 15. So what does that mean? I'm going to write our answer in purple. Our determinant of x is going to equal 2. And that comes from 30 over 15. And our answer for y is going to equal 1, and that comes from the determinant of y, which is 15, over the determinant of 15. 15 over 15 is 1. So our answer is 2, 1. So you can see if you don't need to find the entire solution and you only need to find the solution of one variable, this might be a very easy way to get that answer. However, you might just be most comfortable with substitution or elimination, but the more tools that you have in your toolkit to choose from, the better off you are. Now, here's a great example. I'm going to give you a great example of where you might use, where this might really honestly come in handy. If I have 51x plus 41y equals 24, and 21x minus 18y equals 11, and I said, let's go ahead and find the solution to this system without using a calculator. So no calculator, and I want the answers as fractions. So I'm completely okay with the answers being fractions, and they don't even need to be in their simplest form. I just want the fractional answer. So if you want to try this, you're more than welcome to go ahead and try this. What I would start with is the overall determinant, and the overall determinant is going to be 51, 21 for our x coefficients. Then the next column is going to be 41 and -18. I'm going to have 51 times negative 18 minus 41 times 21. So 51 times 18 looks something like that. So I've got 10 and 2 zeros, and then I'm going to have minus 100 plus 20 minus 2. So 1,000 minus 100 is 900, plus 20 is 920, and then minus 2 is 918. And that would be negative because a positive times a negative is a negative. Minus, I'm going to have 41 times 21. That's going to be 800 plus 40 plus 20 plus 1. So that would be 861. 918, 861, both negative, gives us negative 1779. The determinant of x is going to equal, we're going to replace the x's with our constants. The y column is going to stay the same. I have 24 times negative 18 minus 41 times 11. I'm going to resize this because that's my work. I'm going to change my color to gray so that I can do more work here. And I've got 24 times 18. That's going to be 400 minus 40 plus 80 minus 8. So 440 minus 8 is 432. So that would be a negative 432. Then I'm going to have 41 times 11. So that's going to be 400. 40 plus 10 is 50 plus 1. So that's minus 451. And that is going to be negative 883. And the determinant of y, the x coefficients stay, but this time y is replaced by the constants. 51 times 11 minus 24 times 21. So 51 times 11 is 500. The outer is 50, the inner is 10, so that's 61. So 561 minus, then I've got 24 times 21 is 400. I've got 20 plus 80 is another 100 plus 4. That's 504. And 561 minus 504 is a positive 57. So our answer for x is negative, I was almost going to say 57. It's dx, so that's negative 883 over negative 1779, which becomes a positive result, and our answer for y is 57 over negative 1779. I would just rewrite these. Let me move my work. I would just rewrite these as a final answer, 883 over 1779, and I would write negative 57 over 1779. And that is Cramer's rule. That is Cramer's rule.